All right. Hi, everyone. Thank you very much for joining the conference today. I hope you've been learning new and interesting stuff since the start of the event today and yesterday. I noticed there were some interesting sessions related to responsible AI or serverless. So I hope you have something in your hands to go back home with and try it out. Before I start my session, a little bit about myself. So, my name is Nishu Goel, and I work as a software engineer at a company called The DataWorks. Most of my work revolves around front-end technologies like Angular or React. And whenever I have some free time on, something important or interesting to share, I would just write it down in the form of code labs or blog posts. I am also a Microsoft MVP and a Google developer expert in web technologies. So, the session that I'm going to be talking about to you today is the world of web components. And when I say the world of web components, I kind of figuratively mean it. And the reason for that is if you're into web right now, you would know how componentized the web is, how, broken into components the web is currently. And to understand what I'm meaning here, we would need to dive deeper into how the state of web currently is and how it was earlier, what has changed, what has not. So my talk would be broken into pieces, and this is kind of what it will look like today. So we'll start off with the introduction of what web components are. We'll then understand if there are any standards or specifications to be followed. We'll then look at different technologies and frameworks that allow us or contribute in some way or the other to creating web components or consuming them or just publishing them on npm repository or any other platform. And finally we'll look at why did we come to a stage where we would need web components, why what originates web components, what is the idea behind having to use web components, or what makes it better, or why web components make things better. All right, so let's get started. The first thing that we need to understand is the state of web currently. And to look at that, the best idea would be to, go back a bit and then understand traditionally what used to happen in websites. So the most basic website that I can think of is, an HTML page which has a lot of links on the view, and clicking on one of the links there leads you to another HTML page, which is another set of information in itself. That's like pages to pages linking, and that's kind of your whole website, information website. And after that we had some improvements in how the UI would work, and we would load some data within one view itself. For example, if you click on one button on the view, this would load some other information on the view. This might be another component, or this might be just some set of information which was earlier hidden but then now is showing. And with that, we came to a place where, which is kind of now called single page applications. And this, as the name suggests, is going to be a single page, but has a lot of views in it. And that's kind of what we work on today. We would have this single page, which kind of acts as the placeholder for your different views that you're going to render. And all your routes that you configure take you to another view from this particular view that you're currently on. And the best example to understand this is an e-commerce website, right? You would have a home page at the beginning, and when you select some products and go to the cart, it takes you to the shopping cart. Now, that's not a different page altogether. That's a view, but that opens and renders on the same page. That's why these applications are known as single page applications. And to understand this a little better, you would know that JavaScript is currently ruling the world of web right now, right? And with so many frameworks out there comes a point where it gets difficult to keep up with the changing logic. And but end of the day, all of these frameworks are basically helping us developers do the same thing, which is creating responsive and flexible and efficient UIs, good looking UIs as well. That's what I missed. So, yeah, all of this does basically the same thing. But there comes a point where you reach framework fatigue. Now, this is not a made up term. This actually exists, and this basically means that, with so many frameworks, there comes a point where, you reach this fatigue level. And this is mentioned in the book Web Components in Action. And if you're interested, a lot in web components, you can go and read this book. This would clear a lot of your doubts related to web components. So, that's where you wonder, that maybe I should not have to switch between different components or switch between different frameworks. Maybe you should not have to learn Angular syntax this one week, but then this other week you get a React project and you have to learn the React syntax. You would be okay doing that, for the first framework or the second framework or the third framework. But if this becomes a case for, every time, because there are so many frameworks with something or the other, having an edge on one feature or the other, right? So you would want to avoid that situation that this is what is happening to you every time that you're learning a new framework. And that's where, you would just think a little bit around this and reflect on the idea and think that maybe if all these frameworks are doing the same thing of, helping us develop good UIs, better UIs, and basically all of this is JavaScript, because you see that JavaScript frameworks are mainly, which are a lot of in number, right? So if it's boiling down to JavaScript at the end of the day, what about the idea that you could have this one framework which is boiling down to JavaScript and this other framework which is doing the same thing? What if you could use these interactively? What if, you could use a React component, for example, in an Angular project, or vice versa? You should be able to do that, right? That's kind of where the idea of web components originate from. That's kind of, the need of a developer who's saying that, no, I don't want to now go and learn React syntax. I just want to be able to use my Angular components, which I, toiled in a lot to build. I just want to use them, somehow place them in a React project and be able to, just build my whole React application, or, some part of my React application, with the help of those components. That would be the ideal scenario, right? So let's look at, how, first of all, the web is componentized. Let's look at how one component takes one place in the application, but then it might be needed in some other place also. And let's look at this screen that you see here. And, there's this new arrivals view, which has so many different, parts of the view in it. Now let's consider there's this profile component, which is the first component, the first square that you see. And on the right, you have some, user information, for example, the account name and things like that. And then you have some billing address down in the third, box that you see there. So what if you could use this third box, which is about the billing address and the information, on some other page also? Maybe you would need the same information on the shopping cart page. You could just pick it up from here and place it on the shopping cart page, where you would just display the billing address and, the billing information. That is the need of, having a component as a reusable thing, so you could just pick it up from here without having to do it from scratch everywhere you need it. And this is kind of, a more visual explanation of what we just discussed. So for example, you were working on one framework project, which let's assume was built in Angular, and you did this component that you see has a red background and a cup of, tea or some liquid inside that. And you did a lot of CSS in that, and you really like that now after how it has come out. Now there's a similar requirement in your React project, which is, some other framework project that you see on the right. And that's when you wonder that's when you think of this, the cup, the background component that you did in an Angular project, and you want to just pick it up from there somehow and use it in your React project. What would be, helpful in this case? You will wonder that, what if I could create this as a React component also at the same time? Or maybe what if I could just write it in pure JavaScript so that, I could use it in Angular also and React also? Or what if I could, keep it just like that, the way I created it, but then create it as a reusable piece so that I could just pick it or maybe detach it from the Angular application without having any Angular code in it, and then just place it inside the React project without React having to understand the Angular code, or without you as a, for example, React newbie needing to do any React code inside this Angular component that you're writing. Ideal scenario, right? Which is kind of the best case, because you just want to pick one component which was done earlier in your choice of framework and just place it somewhere which is new for you. So this is kind of, put very much into layman terms about what we are trying to mean here. So it basically says that you have this component that you're really interested in, and you want to create it with the mindset of reusability. You want to create it as a reusable piece, and then you want to share it with, maybe your team or just with yourself in different projects of yours, or maybe with everybody in the world, using it by publishing it to NPM repository or any other repository. And this is a more official, definition of what web components are. And let's break it down and try to understand it. So it says that web components are a set of web platform APIs that allow you to create new custom reusable encapsulated HTML tags. Now, when it says it allows us to create new custom elements, we know that because we are going to write our own logic, our own business logic inside that component. It says they are going to be reusable, and that's kind of the whole idea why we are building our web components. Then it says web components will be encapsulated HTML tags. Now this is a really important part in the creation of web components. So you know how your browser, the DOM, understands a div tag. It understands an h1 tag. You don't have to explain to the browser what an h1 within those angular brackets mean. The browser already knows those. However, if you have a selector which has angular brackets and then it says my reusable component, and you put it inside the DOM, would the DOM understand that? No, right? Because the browser yet doesn't know what my reusable component is. You need to register it with the browser. So the browser needs to know that, okay, this is some element that's coming in, this is some selector, and maybe I have some configuration related to that. So it also says encapsulated HTML tags. And encapsulation basically means that your component should be created in a way that your styles from inside the component or your DOM nodes from inside the component should not leak outside. Should not, your style should not bleed out of the component. And the same exists for the other way around. Like your consuming application might have many classes which might be conflicting with your web component, right? And you don't want those styles to override the styles of your web component because that would totally mess up your code, maybe. So these are some important things that are mentioned in the definition of web components. And then it says that if these web component standards are followed, your web component would basically work across all the different modern browsers, and then they can be used with any JavaScript library or framework that works with HTML. Okay, so let's go one step further and actually try to look at the web component specifications that we have. So there are 4 different web component specifications: HTML template, shadow DOM, custom elements, and HTML imports. But as you see, HTML imports is basically striped off. And the reason for that, so first I'll explain what HTML imports were about. So the way you want to, import one document with another document, just like we use iframes or frame sets, the HTML imports had the same idea. However, due to multiple bugs in those or problems which were not solved, not many browsers could support it, and that's why this was dropped as an idea for web component specifications. Then we are left with 3, which is HTML template, shadow DOM, custom elements. Let's look at HTML template first of all. So whatever your web component code is, you would wrap it inside the template tags. And these template tags basically work like, a container, just like we have ng template in, Angular. So if you're an Angular developer, you would know what's the role of ng template, the selector there. And the idea here basically is that your component, which if contained inside the template tag, would be rendering only when it attaches to the DOM, only when you actually need it. So you don't have to, maybe there are so many images and videos inside your component. Only when the component is needed and is rendered on the view is when your images and videos and all the content inside your component is loaded. So that makes it much more performant, right? Then comes Shadow DOM, which is again a very important, part of web component specifications. And this basically means you would have encapsulated DOM, which we just discussed. It would have scoped CSS. Again, your styles wouldn't leak out of the web component. So if you do document.query selector all and you just specify a node or a class inside that, we would want to ensure that if you're doing that in the consuming application, it should not extract the styles or the nodes from within your web component. It should not have to do that. That's what your scope CSS would mean. That's what Shadow DOM does here. And you could obviously mark everything as every style inside your web component as, important. So to ensure that, it doesn't get overridden, but that's not you would want to do for all your styles inside your web component, right? And maybe it would just not work. And the last web component specification is custom elements. And custom element kind of, holds the base for what web components are. And that's why it's also known as, you could also call it the linchpin in the web component specification, because this is what holds web components together. And the idea is, you would have some custom name for your web component or the custom element, and this would be registered inside the DOM. This is something that your browser will then understand that, okay, my reusable element is looking for this particular component that is registered with the DOM. So once you have that, you would then want to, just look and go forward with custom elements that you just created. Now that your browser understands your component, you would want to have a look at which all frameworks allow you to do that basically. And this is one really interesting website that you could go to, and it tells you that all of these frameworks are compatible with creating a custom element. In what terms are they compatible? How much percent they are compatible? So all of that information for all the different frameworks, which you might not even have heard the names of, you would find that here. So this is pretty interesting. And now, let's look at the stepwise process of actually creating a custom element, a very basic without, depending on any framework, without depending on any technology as such. Using JavaScript, we are simply creating a custom element. Let's see how. So you want a search bar, and it should be reusable, and you should be able to use it inside different, applications which are made out of on different frameworks or, just JavaScript. And this is called class search bar extends HTML element. So your component is basically search bar. And now that you have written, let's assume you've written all your logic for your search bar inside this class, and you want to register it with the DOM now. You want to tell the browser that, okay, there's this search bar component that I've done, and I want you to understand that, okay, there might be, some search bar component that would be rendering in the browser. So don't ignore it, but display it. So you use the define method of the custom elements API, and it basically takes two arguments. One, the name of the selector, basically the selector that the browser will understand, which is in this case ng-search-bar. You could give it any name, and then you give the name of the component. In this case, this should be not search bar component, but just search bar, because that's the name that you've given to your custom element. So the search bar, which is a component, would be rendered in the DOM, and that would be with this selector that you use here. So this will be in angular brackets, ng search bar. And the custom elements API is allowing you to define that and register it with the browser. Once you do that, you now want to understand what are the different life cycles that your custom element goes through once you've created it, once the browser knows that, okay, there's something like that. So the first thing that it does is it attaches to the browser. It attaches to the DOM. That's when connected callback method is called. This works exactly like we have ng on init when your component is rendered and ng on init is invoked. Similarly, when the custom element detaches from the DOM, when its purpose there is done and it has detached, that's when disconnected callback is called. And again, to compare it with an Angular components lifecycle hook, this would be ng on destroy. And then we have many other, different reactions. So we call it reactions and custom elements. However, in Angular, we would call them lifecycle hooks in Angular or React, right? So moving on, just like we have all these framework, terms like lifecycle hooks or property binding or component communication, we also have something for custom elements. So just like lifecycle hooks, we have reactions. Just like input binding, where we do property binding from one component to another. Similarly, we have property binding in custom elements. For output binding, which we do, using output and event emitter in Angular, for example, we have custom events here, which basically ensure that if there's any action that's happening in your web component, which needs to trigger your, consuming application, this is the custom event that would help you to do that. This is the custom event that would send the information from the web component to the consuming application that, okay, there's some change here and you need to update. And then we would have attributes which work like host binding, which helps us change the appearance or the behavior of your host element. For example, in Angular, we have host binding and host listeners, right? So yeah, these are the different things that are related to a custom element. And now you see how you were able to, carry your favorite framework's functionality. Let's just consider that, you have this one favorite framework that you're very comfortable with, and you want to carry the functionality. For example, Angular forms. You love Angular forms, and you want to carry it everywhere, whichever, different framework you go to. So you would just want to carry it from here to the other components, other projects also. So yeah, so let's assume that Angular is your favorite functionality, has your favorite functionality, which is of Angular forms, and you carry it to a React project. You carry it to vanilla JavaScript, and you'll have all that validation working. So the next thing that we come to is polyfills. Now, when you're working with web components, always ensure that you add polyfills, because web components are not supported by every browser, and you want to make sure that whenever you're testing or whenever you're building your web component, it should load in the browser. And to ensure that, you should add all the necessary polyfills. There might be a lot of times in your creation process that you don't come across any such error as such, but then you also don't get to see the view. And that's when you might want to, check for polyfills if your polyfills are working properly. Because when I was creating my web component for the first time, I was struggling with this a lot. I would see no error. I would be completely clueless about what's happening. But then somebody would remind me about polyfills, and then I would be like, oh yeah, let me add polyfills. Not just in the creation of the web component, you might also want to add it to the consuming application. So for example, you created your web component in Angular, a custom element in Angular, and you added all the necessary polyfills. But then you want to consume this web component in a React project. And turns out you don't see any view. You might want to add polyfill to your React project and then check. So yeah, that's about polyfills. Moving on, this was this interesting code that I found on the Drupal website, and this says that as an emerging web industry, web components replace the layout systems, template engines, and endless twig files. And this is just, reminding us again of the importance of web components, about how they're going to replace the whole layout systems that we used to do earlier in the websites, wherein there would be this one sidebar, and then, we would have the whole view towards the right. So they kind of changed it because with web components coming in, we would, just pick something from somewhere and just place it inside the application, make it look good. So they're changing the way web used to be earlier. And now let's look at the different technologies and frameworks that contribute in some way or the other to creation or consuming of your web components. So this is one example that I've put here, which is using lit element, which is by Polymer, and it basically tells you how to create web components using lit element. We have seen the first example where we were creating web components using vanilla JavaScript. There was just JavaScript and there was no other, framework or technology in action. Now let's look at lit element, what it helps us do. So first thing, we need to create a class which is called simple greeting here, and this would be a simple greeting message, or just a hello something, some prompt, which would be this, and it extends lit element. To extend lit element basically means that it will follow all the different methods and properties of lit elements, which is already coming from the lit element library. Then this particular element, which is rendered as hello in the name property, this name property is basically coming as property binding from the consuming application, just like we have input binding. So this property comes in as, it's decorated with this decorator. I hope you understand the, concept of decorators. If you've been working with Angular, you would know that. So this name property comes as a property from the consuming application, and its value is just world here. And you would see that, the whole whatever is rendered would be called hello world, if that's the name value. However, if your consuming application sends some other value for the name property, for example, in this one, we are, rendering this simple greeting element here, and the value of name property is sent as everyone. In that case, your component would render hello, comma, everyone. So that's how you could customize your web component that you just created. And it's a very simple 3 or 4 lines of code that you see here using lit element, which allows you to create your web component. And one important thing that you see here is that your class is decorated with the custom element decorator and then the selector here. This is the selector that you would use in the consuming applications. So as you can see in the second bar here, which uses simple hyphen greeting, that's exactly what is picked from the custom element bracket, the selector that is given there. So that's the selector that you specify for your web component. And now this is the third example that I would give you, and this is using Angular to create your web component. We've seen vanilla JavaScript, we've seen lit element using Polymer. Now we would look at this Angular way of creating your web component and using it or consuming it inside a regular, just a regular HTML file with no framework in picture, with no other technology in picture. So I would just minimize this, and pick this link from here. Go to the browser. Let's go to the browser here, or just open it here. Let's close this. And first of all, let's open the app. So this is in browser IDE, StatBlitz that I'm using here. And we have one root component, which is, app component in an Angular application. And let's go to app.module.ts. And this is basically what we have, when we are declaring or creating our components or directives or pipes or services. Now we have a regular bootstrap array inside the ng module in Angular. If you've worked with Angular, you would know that the bootstrap basically, launches one component to start your application with. However, this is not something that we want in this particular scenario, because we want to create a custom component, to create a custom element on the fly when your application is launching, when your application is bootstrapping. So the manual way of doing it is that you would just comment the regular bootstrap array item which is there, but you will use the ngDo bootstrap method, and inside that you would specify what exactly you want to do when you're bootstrapping your application. So you see how we are using the create custom element method here, which comes from the Angular Elements package. Angular Elements package is what helps us create web components in the Angular framework. It would help us to basically convert a regular Angular component to a web component. So you have a regular Angular component, which is called hello component, and you want to now convert it to a web component. For that, you would use the create custom element method coming from Angular Elements package. And you're doing that inside the ngDo bootstrap method because that's something that you want on the launch or on the bootstrapping of your Angular application. And then you would do any dependency injection stuff here if you want to do that for your web component. And we'll not go into the details of that right now because that's not the focus. And so you see, we have created, first of all, an instance of our hello component, which was earlier an Angular component, but should now be a web component. And this instance is known as ELE. Now that we have ELE as an instance of hello component, the browser doesn't know that yet. So we need to tell the browser next thing. And whenever you want to tell the browser, we need to use the custom elements API and then use the define method, right? So the same thing you would do here, just like we did it earlier in the case of, a regular JavaScript project. So we are using the define method of the custom elements API. We are giving it two different arguments. One, the selector that you would render in the DOM. Second, the instance of the component that you're going to be rendering when that particular selector is seen or rendered in the browser. And for this component, we are just naming it, my comp. You could also name it hello-comp like this. And then that would basically mean that this is what you should render in your component or in your consuming application. So as you can see, let's just pick it up from here, and this will load this particular component. Let's go to hello component and see what it actually, should render. So this is our hello component that was earlier an Angular component, but now we are creating it as a web component. And this one basically says, as you can see the inline HTML here, it basically says welcome to, and then some name property that's coming from the consuming application or just coming from a consuming file, like for example. And as you can see, this name property is coming here through input binding. Since this is an Angular project, you are simply saying, @input, and then this is the property binding happening here, and it would have a string value. So you've specified that in the component. Now let's go to the consuming application. Now your consuming application could either be an Angular, a React project, or a Svelte project, or just a JavaScript project, or maybe just a regular HTML file which doesn't understand anything about dependency injection, anything about component communication. But what it does understand is that if you write something like, this, which is a registered selector in the DOM, if you write something like this in the HTML file, it cannot ignore that because now you've registered it with the DOM. So this should work. And it also basically needs a name property, right? Then only would it be able to show the whole message. So let's go to the, a non-Angular file here, which is the index.html. This has nothing to do with the Angular project. This has no app component or other Angular component that's going on here. So what we simply do is that we would give the selector here, first of all, whatever we have defined there, give it a name property because it needs a name property to be displaying here, welcome to, and then, this is the whole name thing. So you specify the name property, name value, and then you just close the selector that you had given to your hello component. So let's just change this, and let's change the name to be Azure Community Conference. And this would change live. So this is now your web component, which is my com or hello component. And this has the name value coming in from here, and it renders. What if you simply want to, change the message inside your web component? So let's go to our web component, which is hello component ts, registered as a web component. So let's say I am attending, and the name, right? So this is your web component now. And if you go back a bit, right, so as you can see, this is updated now, and you can see that this is what is coming. I am attending is what is coming from the web component. However, the name value, that is coming from the consuming application, which is this particular thing here. You could also try changing the name of the component altogether, or the selector value. And you can see that for the hello component, we have defined the selector here. So let's just call it my, first web, or let's call it reusable comp, which stands for component basically. And this is the selector that you need to now use inside your, the index.html file. Only then would the browser will be able to understand. So let's do that here. Let's change it to this name. And now this totally works, and this knows that, okay, this is the name of the component that is rendered and registered with the browser. And so your index.html file is able to recognize that, okay, this is the same hello component, because in here we are specifying that this selector should work for this particular instance of the component. What is ELE? If we go back one step further, we know that ELE is basically an instance. Sorry about that. ELE is basically an instance of hello component, which we have defined here. Inside that, we could change any content. All right, so this was, the way we could create an Angular component as a web component, and then be able to use that in a regular, HTML file or just a JavaScript project. All right, so I understand that, all of this is not very quick to grab when, there's so much stuff going on. So what I've done here is I created a code lab, and this basically guides us step by step as to what should be done as the first step, what should be done as the second step in the process, or should we follow the web component standards? Should we try to, run our Angular element or the Angular component inside a React project? All of that consuming from the, building process to the following the Angular elements or the web component standards then build a single bundle out of your web component, to then publish it to npm, to then consume it inside a React project, or consume it inside a React or a regular vanilla JavaScript project. All of that would be covered in this code lab, and I'm sharing this link here of the code lab. And you can reach out to me later if you don't find if you forget this link or you don't have it handy. you can just reach out to me. This would basically walk you through all those required, steps in the process of creating the web component. Also, this is the code. This is where I put the code for my first component that I created, or a first, let's call it the first working web component that I created. So that's the repository link for that. And I also put down two different repositories for the applications where I actually consumed the web component that I created. So if you get stuck at the consumption point where you're not able to, use the component that you created inside any other project, these two repositories might help you. And finally, these are some resources that I followed when I was creating the web component and I was diving deeper into what web components are. There's a book about web components in action. There's a video about Angular elements. There's great articles about web fundamentals, which would tell you a lot in detail about custom elements. So these are some of the resources that you could follow. And in the end, I would just like to thank you all very much for staying, up until here to the end of the talk and listening to me. And you could connect with me on Twitter and other places. We have some interesting sessions coming on after this. And there's one about, building your first microservice using AKS and ASP.NET. That is something interesting. So stay tuned. Thank you very much.